Hello everyone, this is Dr. Raviraj M Kulkarni. In this video, I am going to share some tips and tricks to solve numerical problems on mole concept. This video will help our PUC students to prepare for CET, NEET and JEE exams. Time management is very important in these exams. One has to be very quick to solve numericals. The textbook way of solving numericals may consume more time. So I thought I should help the students by giving some tips and tricks and to tell them how to solve in a smart way. Next, what is mole? Mole is the unit of measurement for amount of substance in international system of units. A mole of a substance or particles is defined as exactly equal to 6.022140076 into 10 to the power 23 particles, which may be atoms, molecules, ions or electrons. So we call this as Avogadro number. It is represented by Na or N0. Okay. Relative atomic mass of any element contains the Avogadro number of atoms. So 6.022 into 10 raised to 23 atoms. For example, atomic mass of carbon is 12, which means 12 gram of carbon contains 6.022 into 10 raised to 23 atoms or 1 mole of atoms. Molar mass of any molecules, compounds contain 6.022 into 10 raised to 23 molecules. For example, molar mass of carbon dioxide is 44, which means 44 gram of carbon dioxide contains 6.022 into 10 raised to 23 molecules or 1 mole of molecules. I am giving you some list of common elements and their relative atomic masses. You don't have to remember all 118 elements. So what you have to remember, just 15 or 20 elements. I have given you some. Hydrogen, its relative atomic mass is 1. Carbon 12. Nitrogen 14. Oxygen 16. Fluorine 19. Sodium 23. Magnesium 24, aluminium 27, sulfur 32, chlorine 35.5, potassium 40, calcium 40, barium 137. Okay, so I am giving you some list of important formulae. Number of moles is equal to weight of substance divided by its molar mass. Number of moles is also equal to number of atoms of molecules or molecules divided by Avogadro number. This also number of moles. Molarity is equal to moles of solute divided by volume of solution in liter. Okay, so I'll give an example here. If you want to prepare 1 molar solution of sulfuric acid H2SO4, then you have to dissolve 1 molar mass of 98 gram of sulfuric acid in 1 liter of water. So if you dissolve 1 molar mass of any substance in 1 liter of water, it is 1 molar solution. Some more important formulae. Molality, moles of solute divided by amount of solvent in kg. Only difference is here, earlier in molarity it is liter, now it is in kg. Normality is N is equal to number of gram equivalent of solute divided by volume of solution in liter. Okay, so I'll give an example. Again, the same example I'll take sulfuric acid, but now I'm preparing 1 normal solution. If you want to prepare 1 normal solution of sulfuric acid, then you have to dissolve 1 gram equivalent of sulfuric acid. What is the equivalent weight of sulfuric acid? It is 49 gram. Okay, molecular weight divided by 2, that is number of replaceable hydrogen atoms or ionizable hydrogen atoms. Okay, the basicity is 2, so you have to divide by 2, that is 49 gram. If you dissolve 49 gram of sulfuric acid in 1 liter of water, it is 1 normal solution. Here is one more important formula. Molarity of any solution, okay, is equal to weight of the substance into 1000 divided by molar mass into volume required volume. So you have to remember this formula. How to calculate molar mass of molecules or compounds? So I discussed molar mass of sulfuric acid and all. So I will see how to calculate this. Calculate molar mass of methanol. Molar mass is equal to 1 into carbon plus 4 into hydrogen plus 1 into oxygen. It contains 1 carbon atom, 4 hydrogen atoms and 1 oxygen atom. So 1 into 12 plus 4 into 1 plus 1 into 16. It is 32 gram per mole. Another example we'll take. Calculate the molar mass of sulfuric acid. Molar mass is equal to and 4 oxygen. So 2 into 1 plus 1 into 32 plus 4 into 16. 98 gram per mole. Okay, we'll go to the first question now. Number of oxygen atoms in 4.4 gram of carbon dioxide is 1.2 into 10 is 23, 6 into 10 is 22, 6 into 10 is 23, 12 into 10 is 23. So which option is correct? So to solve this, you should know the molar mass of carbon dioxide. So how to calculate this? 12 into 1, that is 1 carbon atom, 16 into 2, so 2 oxygen atoms, so 44 gram per mole. So number of molecules of carbon dioxide is equal to weight of carbon dioxide divided by molar mass of carbon dioxide into Avogadro number. So 4.4 divided by 44 into Avogadro number, that is what you get is 6.022 into 10 raised to 22 molecules of carbon dioxide. So you have to convert that atoms. Okay, you want atoms of oxygen, so it is multiplied by 2. So this means it contains 6.022 into 10 raised to 22 atoms of carbon and 2 into 6.022 into 10 raised to 22 atoms of oxygen. That is 1.204 into 10 raised to 23 atoms of oxygen. So what is the option here? Option A. So nearest answer is A, 1.2 into 10 raised to 23. Next numerical. 1 gram of magnesium is burnt with 0.28 gram of oxygen in a closed vessel. Which reactant is left in excess and how much? So option A, magnesium 5.8 gram, B, magnesium 0.58 gram, option C, oxygen 0.24 gram, option D, oxygen 2.4 gram. Here you can see, you can just read the question carefully. You are burning 1 gram of magnesium with 0.28 gram of oxygen. So you won't get 5.8 gram from 1 gram of magnesium. So you can easily eliminate option A. Right. Look at the option D. So oxygen 2.4 gram excess. You won't get excess of 2.4 by taking 0.28 gram. Initial weight itself is less, so you won't get this. You can eliminate these two options. So only options left are B and C. We will see. Once we know which is in excess, we can tell that option is correct. One is magnesium, another is oxygen. So solution. Magnesium reacts with half a molecule of oxygen giving magnesium oxide. That is 1 mole of magnesium is equal to 0.5 mole of oxygen giving 1 mole of magnesium oxide. So that is What is the molar mass of magnesium? Is 24 gram, and half the molar mass of oxygen, it is 16 gram, right? So the ratio is 3:2. 3 gram of, you take the ratio 24:16, that is 3:2. So if you take 3 gram of magnesium, you require 2 gram of oxygen. So but we have only 1 gram of magnesium. So how many grams of oxygen is required? 0.66 gram of oxygen. So but we have only 0.28 gram. So which is in excess? Magnesium is in excess. See, 1 gram of magnesium requires 0.66 gram. We don't have 0.66 gram of oxygen, so magnesium will remain in the as a reactant. Okay, it's left in excess. So option B is correct. You can stop here itself in the exam, but still you want to solve this. Okay, we'll solve this, complete this. Oxygen is the limiting reactant. You can eliminate option C as well. Okay, so you can continue and solve the numerical. 16 gram of oxygen requires 24 gram of magnesium, therefore 0.28 gram of oxygen requires how much? So it is 0.42 gram of magnesium. So how much is in excess? 1 minus 0.42 gram, that is 0.58 gram is in excess. So the option is option B. Correct option is option B. Next question. If 3.01 into 10 raised to 20 molecules are removed from 98 milligram of sulfuric acid, then the number of moles of sulfuric acid left are 0.1 into 10 raised to minus 3, 0.5 into 10 raised to minus 3, 1.66 into 10 raised to minus 3, and 16.6 into 10 raised to minus 3. There are the 4 options. Solution. Simple numerical it is. Moles of sulfuric acid present in 98 milligram is equal to what? Is equal to 98 into 10 raised to minus 3, that is milligram I have written in grams. 98 into 10 raised to minus 3 gram divided by 98 gram, that is 98 is molar mass of sulfuric acid. We have already done that. You should remember such things. So what is the answer? 1 into 10 raised to minus 3 molar. So number of moles of sulfuric acid removed, how much they are given? 3.01 into 10 raised to 20 molecules. So that divided by Avogadro number, 6.022 into 10 raised to 23, that gives you molarity. So 0.5 into 10 raised to minus 3 mole. So number of molecules of sulfuric acid left are 1 into 10 raised to minus 3 minus 0.5 into 10 raised to minus 3. So you get, what is the answer? 0.5 into 10 raised to minus 3. So option B is correct. Answer is option B, 0.5 into 10 raised to minus 3 molar. So just remember the formula. Weight divided by molar mass is equal to number of moles. Okay, number of moles is also equal to the number of molecules divided by Avogadro number. That also gives number of moles. So from these two formulae, easily you can calculate number of moles of sulfuric acid left. Okay, next question, question number 4. The number of H2O molecules in a drop of water weighing 0.018 gram is option A 6.022 into 10 raised to 26, option B 6.022 into 10 raised to 23, option C is 6.022 into 10 raised to 19, option D is 6.022 into 10 raised to 20. So solution, how to solve this? Weight of water they have given. So molar mass of water we know 18 gram. It contains what? 2 hydrogen atoms, 2 into 1, 1 oxygen, 16. Okay, 16 plus 2, 18 gram. So number of molecules is equal to weight divided by molar mass into Avogadro number. This is a formula you should remember. If you remember this formula, you can easily substitute and get the answer. So the option is correct. Option is 6.022 into 10 raised to 20. Direct question it is. Simplest question. Only you should remember this formula. Next question. 25 cm cube of oxalic acid completely neutralized 0.064 gram of sodium hydroxide. Molarity of the oxalic acid solution is option A 0.064, option B 0.032, option C 0.015, option D 0.045. Let's see. Solution. Should remember the normality equation, N1V1 is equal to N2V2. Just remember this formula. So what is N1 now? N1 is normality of oxalic acid. That volume of oxalic acid is 25. Okay, 25 cm cube milliliter. So 25 divided by 1000 it is. So if you take this side, it is 1000 divided by 25. Weight of NaOH divided by equivalent weight into 1000 divided by 25 is the formula you have to use, and substitute the values. 0.064 divided by 40. 40 is the equivalent weight of NaOH. Molar mass and equivalent weight are same for NaOH because it has monoacidic base it is. So you get the answer 0.064 N. But they have asked not normality, they have asked molarity. So you need to divide this by N factor. Normality divided by N factor. Number of replaceable hydrogen atoms or ionizable hydrogen atoms in oxalic acid. Oxalic acid, it is 2. So 0.064 divided by 2 gives you the molarity. It is 0.032. What is the option? Option is option B. Option B is correct. 0.032. Okay, so let's go to the next numerical. It's a little bit lengthy numerical, but it's very interesting. 10 gram of a mixture of barium oxide and calcium oxide requires 100 cm cube of 2.5 m HCl to react completely. The percentage of calcium oxide in the mixture is approximately given. Molar mass of barium oxide is 153. So option A is 55.1, option B is 47.9, option C is 52.6, and option D is 44.9. Solution. Let's take mass of calcium oxide is equal to x gram, and mass of barium oxide is equal to what then? 10 minus x. So total mixture is 10 grams. So if I take calcium oxide as x gram, then barium oxide should be 10 minus x gram. Moles of solute of HCl, okay, they are given 100 cm cube is nothing but 100 milliliter. 100 divided by 1000 liters. Okay, you can write that. So 25 molar, 2.5 molar HCl they have told. 2.5 mole per liter into 100 by 1000 liter. Okay, 100 ml I can write, milliliter 10 raised to minus 3 you can write, no? Right, so you get mole, 0.25 mole. So you see the reaction now. Calcium oxide reacts with 1 mole of calcium oxide reacts with 2 molecules of HCl giving calcium chloride and water. Barium oxide also reacts with 2 molecules of HCl giving barium chloride and H2O. See the 2 mole, 1 mole of calcium oxide requires 2 molar of HCl. 1 mole of barium oxide requires 2 moles of HCl. So 4 moles of HCl is required. 4 m HCl is required by 2 moles of mixture of barium oxide and calcium oxide to react completely. Hence they have given how many moles? 0.25 molar HCl is required by How much? 0.125. It should be 0.125. 0.125. Okay, it should be 0.125. So you should remember the formula. This formula you should remember. So equate this. Okay, x divided by molar mass of calcium oxide into 10 minus x divided by molar mass of barium oxide is equal to what? Okay, weight of substance divided by molar mass. Use molarity of calcium oxide. Weight of barium oxide divided by molar mass of barium oxide. Use molarity of moles of barium oxide. So it should be equated to 0.125. Okay, 0.125. So now what I should write? So x by 56. This is 10 minus x. 10 minus x divided by 153 is equal to 0.125. You can easily get x is equal to 5.26 gram. Okay, 10 gram of mixture. Right, in 10 gram of mixture. So percentage of calcium oxide is 52.6. So option is C. Okay, it will take 1 minute anyway. This numerical takes at least 1 minute. Directly you can substitute in this equation. So your approach should be, you remember, so you don't have to write all these steps. Directly write this formula and substitute and get the answer. Okay, x divided by 56, and only thing you should remember how to calculate. Okay, so this anyway 100 divided by 1000 is right, 100 divided by 1000. Okay, it's into 2.5 is 0.25. Directly you have to do it right, and substitute here and get the answer. So it takes 1 minute anyway. Next numerical. A mixture of gases contains hydrogen and oxygen gases in the ratio 1:4 weight by weight. What is the molar ratio of the two gases in the mixture? Okay, it's the most simplest question it is. So they have given the ratio 1:4. So moles of hydrogen, you can write weight of hydrogen divided by molar mass. So x, if I take molar mass of hydrogen, molar mass of hydrogen is 2 gram per mole and molar mass of oxygen is 32 gram per mole. Okay, so if x is the weight of hydrogen, then 4x will be the weight of oxygen. They have given 1:4 weight by weight. Right, so you substitute. Okay, if I take x as weight of hydrogen, you have to divide by 2. So if I take 4x, okay, then weight of oxygen is 4x divided by 32. So x by 2 divided by 4x by 32, that's the ratio. Okay, so x by 2 divided by 4x by 32, I can multiply it now, 32 by 4x. Okay, so this x you can cancel. Okay, so 2 ones are 2, 16, again you can write 16, right, 4 ones are 4 fours are, so 4 divided by 1. So normality, sorry, that ratio becomes, mole ratio becomes what? NH2 divided by NO2 is 4 by 1. So answer is A, 4:1. Next numerical. How many gram of methanol should be added to water to prepare 150 ml solution of 2 molar methanol? Okay, so you remember I have given one equation. What is that equation? Molar, first we'll see what is the molar mass of methanol. Methanol means CH3OH. We have calculated it contains 1 carbon, 1 to 12, 4 hydrogen atoms, 4 into 1 right? 1 oxygen 1 to 16, so 32 gram per mole. So I have given this equation in the beginning. I told you to remember this. So molarity of any solution is equal to what? Weight of substance into 1000 divided by molar mass into required volume. But we want what? We want 2 molar solution. So they are asking the weight here. So weight is equal to what? Weight is equal to, weight of the substance is equal to, you take this 1000 that side, volume required also this side, molar mass also this side. So weight of methanol is equal to molar mass into molarity into required volume divided by 1000. So this comes out to be 32 into 2 into 150. 32 is the molar mass of methanol into 2, that is the molarity. You want to prepare 2 molar methanol, they have asked you to prepare. And required volume, how much it is? 150 molar, 150 ml, sorry, into divided by 1000. So you get 9.6 gram. So what is the answer? Answer is option A, 9.6 gram. Okay. Let's solve one more numerical. Which of the following has the maximum number of molecules? A, 32 gram of oxygen, B, 4 gram of hydrogen, C, 7 gram of nitrogen, and D, 46 gram of NO2. So solution, okay, mass of oxygen, molar mass is 32 gram, molar mass of nitrogen is 28 grams. We know all these things. Molar mass of hydrogen is 2 gram, molar mass of nitrogen dioxide is 46 gram per mole. Number of molecules is equal to what? Weight of substance divided by molar mass into Avogadro number. So you can calculate molecules of oxygen, okay, 32 by 32 into Avogadro number, 4 by 2 into Avogadro number for hydrogen, nitrogen 7 by 28 into Avogadro number. So NO2, the molar mass is, it contains 1 nitrogen and 2 oxygen, 32 plus 14, so 46 gram, 46 by 46 into Avogadro number. So which has the highest? Answer is B. See, it is 2 into Avogadro number, rest is nitrogen is 1.25 into Avogadro number, nitrogen dioxide is just an Avogadro number, and oxygen is also Avogadro number. So 2 into Avogadro number is maximum. So maximum number of molecules are with hydrogen. So option is B. Okay, B is the answer. Option B is the answer. Okay, I hope you enjoyed my video. Okay, if you like my video, please click on subscribe button to subscribe my channel. Like and share the video. If you have any doubts, then write to me. Dr_Kulkarni _1976 at yahoo.com. You can also comment on the video itself. Okay, thank you for watching.